Hello, Granada. This is Mr. Meyer coming at you with operations of functions or with functions, and let's talk about a little bit of fun that you can have. Now, this is something that you're going to feel pretty comfortable with at first, so that's good. It's going to be operations, adding, subtracting, multiplying, dividing, and you can do them with functions just like you do with numbers or like you do with expressions. You pretty much just find like terms and reduce stuff or factor stuff if you have to or FOIL it all out. So all should be pretty good and you'll like it. Now the funny part though is the way it's written. Like let's talk about addition and notice this little box in the middle of the screen. They can write it like this or they can write it like this. It means the same thing. It means add the two functions together. In other words, really just combine like terms. Notice subtraction has two ways. Notice multiplication has two ways, and that's probably the most confusing one. Not here, but in a little bit, we're going to talk about composition where they use an open circle, and that means something different than this filled in circle. So make sure you know the difference, right? A filled in circle means multiply, means just multiply the two functions together. You're going to want to draw your box, or you're going to want to FOIL, or you're going to want to distribute, whichever method you prefer. And division, just make sure that you cancel any factors that you have. So with that being said, let's get on to the examples. So here's examples 1 and 2. Let's talk about example 1 first off. You might notice that I tell you what function f is, and I tell you what function g is. So let's go ahead and add those two functions together. So you can think of this as you just take f of x and you add it to g of x. And so now use substitution, right? I'm going to take out the word f of x and I'm going to type in 4x squared plus 3x minus 1. And then I'm going to add to that all of g, which is 6x plus 2. And now if you go ahead and you add those two things together, combine like terms. You got 4x squared plus 9x plus 1. And we have our equation f plus g of x. Or if you want, you can write it the other way. And there's your answer. Nice, right? Finished, done, happy. Move on. Let's talk about subtraction. Subtraction, of course, is going to be the ugly mean one because of the fact that everyone forgets to distribute the negative sign through. So let's go ahead and try that right now. So I'm going to take f, 4x squared plus 3x minus 1, and I'm going to subtract all of 6x plus 2. So notice the parentheses this time because I'm subtracting all of g. If you want, you could definitely write it like this again. Hopefully that reminds you to put the negative in on all of g. But now go ahead and combine. Sometimes you know me, I like to distribute that through just so I don't make any goofball mistakes. So minus 6x minus 2 and combine like terms. 4x squared, minus 3x this time, minus 3. And there she is, all done. F minus g of x is that answer. And you have now done addition, some operations with functions, right? You've added two functions together and you've subtracted two functions together. They do get a little grosser, as you'll see in example 2. So let's create two new functions. So we got function f, we got function g, and this time notice we're going to multiply. That's like f of x times g of x. So depending on your mood, are you a person who draws a box? Are you a person who draws arrows? I think somebody calls it the rainbow method or something like that. It doesn't matter to me. You take all of f and you multiply it with all of g, and then just do your method. If you're going to distribute, draw your arrows, awesome. Whatever. I'm going to draw the box today. So I know it's a 2 by 3 box. So there's the 2. So here's the 3. So I have a 2x minus 3, and I have a 6x squared minus an x minus a 12. And I'm just going to multiply this out. So 2x times the 6x squared, that's what, 12x cubed? Yep, and that's good. And now I can do it with the negative x, so negative 2x squared. And now with the negative 12, negative 24x. And now if I go ahead and multiply the next one through, I get negative 18x squared, I get negative or positive 3x, and I get positive 36. And we have just done multiplication. Now be careful. 12x cubed But then here, look at, there's 2x squared, so combine like terms. So negative 20x squared. Look right here at 24 and a 3, so that's what, negative 21x. And then plus the 36, and there she is. That is f of g of x. Because I could have written that f of g of x. Beautificent. All right, last but not least, let's look at division. Now, division, be careful. Sometimes it's really simple. Sometimes you luck out and you just do the division and you don't have to do anything, right? You just write 6x squared minus x minus 12 all over 2x minus 3, and you're done. But there's a little part of me saying, I wonder if this top factors, right? There's a little part of me that says, I wonder if. So real quick, you know me, I'm going to do my bottoms up. So yuck, this is pretty big. 6 times 12 is what? Negative 72, and it's got to add up to negative 1? Now I got to sit and think for a second. What numbers multiply to 72 that are going to add up to just a negative 1? Isn't there a 9 times 8 in there? Yes, a 9 times an 8. Now I got to be careful. 9 times 8, I got to put the negative on the 9, and I am feeling good. Now my bottoms up method's again a little weird. You divide by whatever number was out front. So I got to divide this by 6. I got to divide this by 6. I reduce those fractions, which would be 4/3 over here. And it looks like 3 goes into those, negative 3 halves over there. So there's my factors. One factor is 2x minus 3. And the second factor is 3x plus 4. You can FOIL that out if you want to check. Oh, and look at that. I am very happy that I factored that because the 2x minus 3's cancel, and your final answer is 3x plus 4. So if somebody asks you, hey, what's f over g of x? You could tell them, it's 3x plus 4, and you're done. All right, let me ask you a couple questions, and I'll be right back. All right, there's also another way to combine functions, and it's called the composition of functions, where you plug one function into the other. And that one's a little insane, and it involves this open circle that I kind of mentioned earlier. And so some people will call these fog problems, right? Because the fact is it looks like the word fog. And so what that means is you substitute one function into the other. So a fog problem, you're going to take g and you're going to plug it into f. Whatever your answer was for g, you'll get that answer and you plug it into f. So remember, in math we work in the innermost parentheses and we're going to solve it backwards. So kind of look down here at example 3a. The first thing you want to do is figure out what the heck is g of 4. So in other words, I want to go to g and I want to plug a 4 in. That's what g of 4 means. So if we plug it in, we plug in a 4, we get 7 minus 4, we get 3. So g of 4, the answer is 3. That now means we need to figure out what f of 3 is. So in other words, the answer to g gets plugged into f, and that's what f of g means. So I'm going to take g's answer, 3. I'm going to plug it into f, so I'm now going to get 2 to the 3rd power, and we know that that is 8. So our final answer is 8. So f of g of 4, that would equal 8. That's your answer. A little crazy, right? But you just got to go in order. You just got to do exactly what it says. So look at B now. B tells me that I want to do first f of 4. So I'm going to go to f, and I'm going to plug in a 4. So that would be 2 to the 4th. So what is that? 16? So 2, 4, 8, 16. Yeah. Now that answer's got to get plugged into g, is what this is telling me. So I will do g of 16, which is 7 minus 16, which I believe is negative 9. And there is my final answer, negative 9. So I have g of f of 4 is equal to negative 9, and that is my final answer. Now that's the nice way. That is, you give me a number and I will plug it in whatever order you say, and I can follow the instructions that are laid out, like g of f or f of g. Not a big deal. Gets a little trickier when someone says, what would the function be if you plugged it in? In other words, don't give me a number, just leave the x's there and plug the function in. Now you have to be super careful. Just like before when I took the x out and put a 3 in, same thing's going to happen here. We're going to take the x out and put something in. Sometimes people forget to take that x out. So you'll see what I mean. First thing I see is this composition right here. It could have been written like that, or it could have been written as fog of x. Now I don't like the fog way. I would always rewrite it the way you see on the screen, so that's the way I would write it. But just be aware it could be written as fog. And all that means is I'm going to take equation f and I'm going to plug g into it. So this was g, right? And I'm going to plug it into it. So just like you have f of 2, you plug a 2 in, you take the x out and you plug a 2 in. Or if you have f of 7, you would plug a 7 in. I want you to plug this gross stuff in, this highlighted gross stuff. I want you to put that into f right there. So again, we're going to go over to equation f. We're going to take the x out and we're going to put this highlighted in stuff in. And it would look like this. Now sure, you can definitely go ahead and clean that up a little bit. I think squaring that would be x squared over 1 minus x squared minus 1. You can leave it at that if you like. You could also get a common denominator and clean it up if you want. But I think I'm going to leave it like this. Now it says state the domain. Look at that function. What's not allowed here, right? X cannot equal 1 because if it does, we have a 0 in the denominator. And so therefore, my domain is all real numbers, so all the x's such that all x's except for -1. And done. So there's my domain. Now you can do all this, you can do the same thing on B, but notice what B is saying. B is saying I want you to take f into g. So again, I'm just going to copy the g down. I'm going to write in what equation f is, x squared minus 1. Now all that means is go ahead and take this x squared minus 1 and plug it into g. So go to g and see wherever you have an x, take it out and put it in x squared minus 1 and you should be golden. So when I do that, I would have, all right, x squared minus 1 in the top. And in the bottom, 1 minus x squared minus 1. Notice the parentheses because that negative is going to get distributed. I could factor the top to x plus 1, x minus 1. I can kind of clean up the bottom. Looks to me like negative x squared, and then that's going to be a plus 1. So that's plus 2. What could you do here? You could, I don't like that negative in front of my x squared. I can't factor it any. I could move the negative out front, but notice what it'll do to the bottom. You'll have x plus 1, x minus 1. But on the bottom, if you pull that negative out, you'll have x squared minus 2 now because you had to pull that negative out of everything in the denominator. There's your fraction, right? You're done. Now, yes, you could have left it in the step before. Also, you better tell me about the domain. So for the domain, we cannot let x equal square root of 2. Now, how did I get that? X squared minus 2 equals 0. We can't have a 0 in the denominator. Move it over. X squared equals 2. Square root this bad boy, and you get plus or minus root 2. So x cannot equal plus or minus root 2. Again, we just want to make sure that we don't have any zeros in denominators because that always causes trouble. Negatives under square roots are bad if we're talking about real numbers like we are in domain, and zeros are bad in denominators if we're talking about real numbers. So make sure you always take care of those. And that's it. That's your composition of a function where you plug one function into the other. Now we're going to give it a try in class tomorrow. So you guys have a great day and stay happy.